Okay, we got another case study here in the class. It is a 2000 Ford Focus, and as you can see, we have multiple trouble codes. First thing I want to mention on this one is this P0171 code and this mass airflow sensor circuit code, sensor intermittent. Mainly the P0171 code. One of the things that you guys in the field want to remember not to do is to put one of these intakes on these cars. And you see it's a, quote, cold air intake. It's that special intake manifold. And big problem here with this design is when you take the PCV system and you just put one of these little breathers on it and you basically take the PCV out of the loop, you are going to generate a lean exhaust code that you're not going to ever get rid of. So we're not going to worry about the lean exhaust code for this car. We're going to address the EGR one. That is our main focus here. So back to the scan tool. Sorry, Brandon, I had to do it. All right, so we're going to address this P1409 trouble code, this EVR control circuit fault. And one of the complaints that the owner of the vehicle has is he has a pinging problem. And that would kind of make sense that we have an EGR valve issue. EVR solenoid is EGR valve regulator. And we have a circuit fault. So we're going to walk through the EGR system on this, addressing the EVR solenoid first. Okay, a couple things I want to point out on this design. This is the DPFE sensor right here. It's a delta pressure feedback for the EGR system. That's what it stands for. That is the pressure sensor that monitors the system. Right below that, right here, is the EVR solenoid. This EVR solenoid we've talked about in some other videos I've done. It is ground side switched. It is a duty cycle controlled valve. Computer's going to control the on-off pulsing of this valve, which is going to control the amount of vacuum to the EGR valve, which is down here. So it is a vacuum controlled EGR valve. The computer controls the EVR regulator to open the valve, and the DPFE is going to report back the proper flow of the EGR system. So that's just a quick overview of this design. Alright, so with this EVR trouble code, we're going to start with testing the EVR solenoid for voltage on both wires. This being a ground side switch circuit that with the key on is not being energized, we should have two 12-volt feeds, one going in, one coming out on this solenoid. So we'll take our first of our two measurements, will be the wire to the right. We are already connected our scope or voltmeter positive lead to that wire, and negative lead is on the battery. Here's our scope negative lead, and we get a voltage reading using the Varus here for this one. And you can see that we have 12.42 volts on that one wire. Now I'm going to move this T-pin over to the other wire. We'll take a reading on the other wire. So I am connected to that other wire right now, and we have a reading basically of 0 volts. I think that says 0.08, 0.09 on the screen. We have 0 volts on the other wire that should be reading 12 also. So I'll give you a shot of where we're connected. We just moved this T-pin over one, taking a measurement on that wire. So this being a ground side switch circuit that reads 12 volts on one wire, 0 volts on the other, that would be what a ground side switch circuit would look like if it was being turned on. So it should look like that if it was being turned on. The problem is right now with just the key on, that circuit should not be being turned on. So we have an issue here. We either have a short to ground in the control wire, a shorted driver where the computer is grounding it all the time, and by the way, a short to ground in the control wire would also ground it all the time, providing 0 volts. Another option is going to be an open solenoid. I addressed this procedure in section 3 in my book, Computer Output Solenoids and Transistor Drivers. There's procedures in there that are exactly what we're doing. For me, the next easiest step I want to address, is this circuit being turned on, causing 0 volts all the time, or is the solenoid coil open? And the next easiest step for this right now is going to be to take a test light, connect that test light to battery positive, and touch on that T-pin. If this circuit is being turned on by either a short to ground in the control wire or a shorted driver, that test light's going to light. You want to go ahead and do that for me? Test light's going to be to battery positive. And we always want to double check our test light and make sure it functions. So when we touch ground, you can see that that test light is lighting. And we're going to go over and we're going to touch it on the T-pin. So we are touched on that T-pin right now, on the control wire, and you can see that that test light is not lighting. So what that means is our circuit is not being turned on. There is no short to ground in the control wire. There is no shorted driver. That leaves us with one option, guys, and that is an open in the solenoid coil. So this trouble code, let's think about the code for a second. How's the computer setting this code? We have an EVR solenoid code. The computer right now has an output state monitor that is watching that circuit, and it wants to see 12 volts on it with the circuit off. 12 volts on the control wire with the circuit off would be no trouble code. Okay? 0 volts on the control wire with the circuit off, it's going to flag a code. And that's what's happening on this car. Now we can confirm this test if you guys would like. Some of you like the ohm meter, so we can go ahead and do that. Next thing we'll do is we'll ohm the solenoid. What we're going to find is very, very high resistance, probably an open coil on this solenoid. We'll do the ohm check next. Okay, I'm doing an ohm check on this solenoid. If what we did so far is correct, when we do this measurement, it should stay OL M ohms, which is the scale I'm on right now, which is a mega ohm scale. So I want to reach in and I want to touch these two pins. So touching the two pins, as you can see, that confirms our call. This solenoid is open. The next thing that we want to do, we're not totally done with this. We want to make sure all the other components work on this car. And one of the things that I'm always worried about when I have an open solenoid is to make sure that the computer driver can still function. And now a problem that you're going to run into as far as the driver goes is with the solenoid out of the picture, because we can't use it to monitor voltage drops, is we need a way to check this computer driver. We need a way to check the control wire and make sure it's not open. And it's a very simple test from this point, knowing that the left side of the connector is my control wire based on our voltage readings. The right side is the feed. I'm going to take that same test light to battery positive, and we're going to touch on the control wire, and then we're going to take the scan tool in a bidirectional mode and command this EVR solenoid to turn on. So that's going to be our next step. Okay, I'm under my functional test mode on the scan tool. And the test that we're going to pick is this EGR vacuum regulator on-off command. So we're going to hit that. And under this test mode, we have an on-off at the top of the screen that we're going to alternate. Get you up there so you can see it. We're going to alternate and toggle this solenoid on and off just by simply hitting the button here to turn it on, hitting the button again to turn it off. And we're going to see if our test light lights. If the test light lights, that's going to tell us that that control circuit is functioning normally. Tells you the control wire has no opens. And also tells you that the driver's functional. And that's what we're worried about. So we'll go down to the connector and take a look. And you want to hold that on there. One of the important things here is to make sure that you do not stuff this test light into this female pin. That test light is a much bigger diameter. If you were to do that, it would never contact the solenoid properly anymore. So we're just touching it on there. Can you move your index finger so I can see the, there you go, perfect. I'm going to command this circuit on. So I just hit on. Test light did not light. That's not what we want to see. Turn it back off. Okay, one of the things that we need to be careful of with this kind of situation, sometimes a computer will turn an output off and completely disable it. Now it's working. Okay, good. What I was going to tell you is if this test does not function, what we might have to do is clear the trouble codes. With a hard fault in memory, the computer may disable that output. But you can see right now it is functioning. Turn it off and turn it on. And what that's going to tell us right there is that that computer driver is functional and that control circuit between the solenoid and the computer is fine. and we can go ahead and safely and confidently put a solenoid in this car. So it needs an EGR solenoid. Probably in this case too, you would want to check the DPFE sensor and the EGR valve itself, and we can do that test and show you that part next. Okay, there's a couple different ways to check this DPFE sensor, and of course we're limited in some of the tests because the solenoid's bad. One of the ways we could do it is energize the solenoid, engine idling, look for a rough idle, look for the DPFE voltage to change. I've shown you that in other videos. In a case like this, I think one of the methods that's important to show is that you can check just the DPFE by itself, and what you would do is leave the key on and you disconnect the smaller of the two hoses on the DPFE sensor, take a hand vacuum pump to the smaller port with the key on, and you monitor your DPFE voltage, and it should increase to over 4 volts as you apply vacuum to the smaller of the two ports. So I'm going to show you that one. Okay, see I have a hand vacuum pump connected, and I'm connected to the smaller of the two ports. I'm just going to pump vacuum on that smaller port, and we're going to watch our DPFE voltage on the scan tool. With the key on these Fords, I don't like that number. I might be trapping a vacuum in here. Let's see. I was. Okay. So on these Fords, generally under a volt, they change a lot as far as numbers go from car to car. 0.6, 0.7, 0.8. Generally under 1 volt for these DPFE sensors would be normal numbers, and I'm at 0.98 of a volt. I'm going to take this hand vacuum pump now, and I'm going to pull a vacuum on the smaller port, and as I do this, we should see this signal voltage rise. One of the things that we should have done is we should have limited our data PIDs to see a little bit faster of an update here. But you can see with a vacuum pulling on this that it's going up over 4 volts, which is what you want to see. So that is a good DPFE sensor. Very quick test on the DPFE itself. That's how you would isolate it. Again, pull a vacuum on the smaller of the two ports on the DPFE sensor. So DPFE looks good. One other check on this EGR valve system would be to start the car and pull a vacuum on the EGR valve and make sure the idle gets real rough and that the engine stalls, and that's going to tell you that your passages are clean. So that would be the last step in this. Alright, so we started the car. I know what some of you are probably thinking. This is a mass airflow engine. We're running it with the mass airflow unplugged. That's okay. Ford has good backup strategy, so you hear the car's not running too bad with that out of the picture. Checking the EGR, I'm just going to pull a hand vacuum pump on the valve, and we're going to listen for the RPM to get real rough. We want it to just about stall the engine out. So I like the result of that test. That tells me the EGR valve is also good. Tells me the passages are clean, and that when we put an EVR solenoid in this car, we shouldn't have any problems at all with this EGR system. So Ford EVR solenoid trouble code, open solenoid. We identified it using voltmeter test light as far as direction. We checked the computer driver. We checked the DPFE. We checked the EGR valve. We're going to replace this solenoid, and I'm going to show you one final test that checks everything all at once. Okay, with the new solenoid installed, we have the key back on. We're going to retrace some of our steps. We're going to do our 2 voltage measurements first. This is on the wire to the right, which is our feed wire, and you can see we have battery voltage on that wire. Disconnect my T-pin from there, put it into the control wire, and now that we have a good solenoid in place, you see that we have 12 volts also on the control wire. And so what that tells you is that power is going into the winding, wrapping through, coming back out, looking for a ground. So that's a fix as far as the solenoid goes. 2 different ways we can go about this from here. We can energize the solenoid manually, force the valve to open. We can show you that one. And then we can also bidirectionally control it, and I like that method too. Okay, I'll show you the test light method first. This will be a complete test other than the driver. So we're checking everything in the system with this except for the computer driver. It's a ground side switch circuit. We're going to take a test light to ground and we're going to ground the control wire. Quote, being the computer, grounding the circuit. If this solenoid functions, the RPM should get real rough. The DPFE voltage should rise. And do the test first. Stalled the car out. There's no problem with that. It should get real rough or stall, and what that tells you, the solenoid's functioning, the valve is opening. One last thing we want to look at for that test, make sure the DPFE voltage is rising. So I'll get you back to the scanner. I'll get you on that DPFE voltage, and then we will redo the test. Turn your key back on. Actually, you can start the car. All right, I'm going to energize the solenoid again, watch the DPFE voltage on the scanner. Start the car back up. Hold your foot off idle just a little bit, like 1500. Energize the solenoid. Okay, good. All right, so what you saw there, of course the car stalled. We couldn't get that update on the scan tool that fast, and on that test we held it at about 1500. Did the test, opened the EGR. We had over 4 volts on the DPFE. That shows you good flow. In fact, that's the final test you do anyway, is hold your RPM up, make sure you're going over 4 volts. That's a good DPFE signal. The last one that I can show you would be the scan tool bidirectional control, and this one's going to go just a little bit further in that it is also going to test the driver. So let me show you this one real quick. We'll just exit out of here. Go to our functional test, go to our EGR vacuum regulator duty cycle, and on this one we're going to open the EGR valve in increments, and it should get real rough. It's going to be on a timer, so it's not going to let me do it for very long. You can watch your DPFE voltage here on the right while we're doing this. Hit the test button, and then what we're going to do, we're going to scroll in a higher and higher DPFE percentage. Sorry, a higher and higher EVR percentage. Idle's gotten real rough. Hold your RPM up a little bit. We want to see that DPFE go over 4. Good. All right. Let it idle. Scroll it back down. So that test is actually a little bit better than the test light one in that we check the driver as well. Now that test isn't available on all the Fords. You can't always do that, so it helps to know how to do the test light method too. But that is the complete test on this Ford EGR system.